Hi students, today's topic is Booth's algorithm for binary multiplication. This is the third method for binary multiplication. It will speed up the multiplication process. It is an efficient method for binary multiplication, and it uses 2's complement representation, also arithmetic right shift. Since it is uses 2's complement representation, it is applicable for both positive and negative number multiplication. Okay, now we have 4 registers, that is multiplicand is stored in M register. There's a register, this is temporary storage register. This Q register, here the multiplier is stored in Q register, and there is a Q minus 1 register which is 1 bit register, and a counter register which is n bit register. All the registers are n bit except this Q minus 1 register which is 1 bit register. Okay, so here n number of bits involved. Okay, here the counter register carries the number of bits. If it is a 4 bit, then the counter n become 4. Okay, and so A, M, Q, CR and n bit register. A, M, Q and CR and n bit register, and Q minus 1 are 1 bit register. Okay, so in this case, we are using this Q0th term. This is Q register. This is the LSB term of Q, that is Q0. We are combining Q0 register and Q minus 1 register. If Q0 register and Q minus 1 register jointly 0, 0 or 1, 1, then shifting operation is done from A, Q and Q minus 1. So the value of A will move to Q, and the value of Q will move to Q minus 1, and the value in the Q minus 1 will be drop out. Okay, this is when the shifting operation done when the Q0 and Q minus 1 value, that is LSB of the multiplier and Q minus 1 value, if it is 0, 0 or 1, 1, the shifting operation will done. Okay, then if it is 0, 1, if the value of Q0 is 0 and value of Q minus 1 will 1, then it is 0, 1, then A plus M is okay, A will be added to M. If that is when Q0, Q minus 1 will be 0, 1, A will added to M. If Q0, Q minus 1 value is 1, 0, then A is subtracted from M. So that is A minus M will be processed. Okay, this is the hardware part of this Booth's algorithm and the operation of Booth's algorithm. Okay, this can be explained by using an algorithm, that is load the multiplicand in M, multiplier in Q register. Okay, in M multiplicand and Q register multiplier. The second step is clear registers A, Q minus 1. Okay, and also here for negative numbers 2 complement form is used. Okay, for negative number we are using 2's complement form. If it is Q is negative number, then use the 2's complement of Q. If M is negative number, use the 2's complement of M. Okay, so 7 minus 3, if it is 7 minus 3, so in order to get minus 3, we want to take the 2's complement of 3. So it will be stored in the register. Okay, then the second step is clear A and Q minus 1. Clear the A register and Q minus 1 register. Then next initialize the counter by the number of bits. Okay, then the counter value will become the number of bits value. Okay, if it is 4, the counter will become 4. Okay, then next step is check the LSB of Q and Q minus 1 jointly. Check the LSB of multiplier Q, that is Q0 and Q minus 1 jointly. If it is 0, 0 or 1, 1. If it is 0, 0 or 1, 1, then go to step, that is perform right shift from A, Q and minus 1. If it is 0, 0, that is Q0 and Q minus 1. If it is 0, 0 or 1, 1, then shift from A, Q and Q minus 1, right shift. Okay, then if it is 1, 0, then A have A minus M. If it is 1, 0, we have A minus M. Subtract A with M and the answer will be saved in A. If it is 0, 1, then add A plus M and save the value to A. Okay, then after that perform the arithmetic shift A, Q and Q minus 1. Shift A, Q and Q minus 1. Okay, then the sixth step is decrement carry register by 1, count register by 1. So one process is completed, then decrement to 1. If CR not equal to 0, then go to 4. Then 4 step is repeated. If count is 0, then we get the final answer, and the product is available in register A higher part and Q in lower part. After completing the procedure, A and Q contain the result. Higher bits of which will be contained A and lower bits are contained in B. Okay. So the number of iteration cycle in both algorithm which will be equal to number of bits involved, that is n. Okay. This is the hardware implementation of Booth's algorithm. Okay. Now we can see a flow chart. Okay. That is, we start the operation. Initially we set M has multiplicand and Q has multiplier, and set A equal to 0, Q minus 1 equal to 0, and count register equal to N. Okay. Then first we check Q0, Q minus 1 value. If it is 0, 0 or 1, 1, perform arithmetic shift from A, Q and Q minus 1. If it is 0, 1, add A plus M and save the value to A, then shift. If it is 1, 0, add A minus M, and the answer is given to A, and then right shift A, Q and Q minus 1. Then after that decrement 1 count. Then if the count register is 0, stop the process. If it is not 0, repeat the process. Okay. This is then the final answer will be A and Q in 2's complement representation. Okay. So this is the explanation for this flowchart.